Welcome back to Mr. Hassan's Maths channel. I am now answering upon the request of one of my viewers a question from the June 2016 International A-Level Edexcel Statistics 1 S1 paper. This is question number 4. A researcher recorded the time T minutes spent using a mobile phone during a particular afternoon for each child in a club. The researcher coded the data using V equals T minus 5/10, and the results are summarized in this table. So the times that they found that each child used the mobile phone, they took that time, they subtracted from that time 5 and divided the answer by 10, and those were the values that they put into this table, and the values that they came out between 0 and 5 were placed in this category here, and there was 20 of them. And the values between 5 and 10 in this category here, there was 24 of them, and so on and so forth. So this is a frequency table for the coded time, not the actual time. And it's a frequency table, so we don't know the actual values of V, but we know that 20 of the values of V between 0 and 5, 24 between 5 and 10, 16 between 10 and 15, and so on. And they've given us a third column here, which is called the coded time midpoint, M. They've called that M, which is basically the mid-interval value for each of these intervals. So you can see 2.5 and 12.5 and 17.5. Those are the mid-interval values for all of these intervals here. So they've given us two that we don't know, and they've told us to write down the value of A and the value of B. So we just got to find the middle of this interval here, which is between 5 and 10. Now, if you're not sure how to do that, it's very simple. You just basically find the average of those two. So you take the beginning of the interval and add to it the end of the interval and divide by 2. That's going to give you 15/2, which is 7.5. And for B, you got the beginning of the interval, which is 20, plus the end of the interval, which is 30, divided by 2. That's 50 divided by 2, which is 25. So that's going to be 7.5, and that's going to be 25. Sorry, 20.5, 25. Okay, so there we have the answer for part A. Pretty simple. Then it says part B. It says calculate an estimate of the mean of V. An estimate of the mean of V. Now, the mean of a set of data is the sum of all the values in that data, the sum of all the entries in that data, divided by the number of entries in that data. So you've got to add together all the values in that data and divide by how many entries there are. Okay, so in this case, we don't know what the actual values of V's or the V's were. Okay, we have to find the estimate of the mean of V, which is the coded times. So we don't know the actual values of what the times were, or the coded times were, but we know that 20 of them were in this category, and 24 in this category, and 16 in this category, and 14 in this category, and so on. So what we're going to do is we're going to use the mid-interval value, which they gave us for each of these, and asked us to find 2 of them, to help us to estimate the sum of all the values in the data. So I know that there's 20 values which are between 0 and 5. I don't know exactly what that value is, but I'm going to say let's assume that they are 2.5. So I'll do 20 times 2.5. Then I'll add to that 24 times the midpoint of this, which is 7.5, and 16 times the midpoint of this one, which is 12.5, and 14 times 17.5, and 6 times 25. So basically what I'm going to do is I'm going to multiply the frequency by the midpoint for each of these and add them all together. So that's called the sum of FM. And that's exactly what they gave us in this statement here. So sometimes they give you things that you need to use, and you could calculate, but they actually give you the values to save you some time. So we know that the sum of FM is 825, so I don't have to bother going actually doing the calculation, which I just described. I can just use that value. So I'm just explaining this to you, so those of you who need to understand what exactly these things mean. So to find the estimate of the mean, and this of V, so this symbol here means the mean of V, so I'm estimating it. Why are we estimating it? Because we can't actually find the real value because we don't know what the values of V are, so we have to estimate using the midpoint. Okay, so anyway, so the mean is the sum of all the entries, which is the sum of FM divided by the number of entries. Now the number of entries is basically the number of children in this survey that were surveys, and there's basically the sum of all the frequencies will tell you the number of items in the data, the number of children surveyed. So that's 20 plus 24, which is 44, 44 plus 16, which is 60, and that's 74 plus 6, which is 80. So there's 80 items of data. So you've got to divide this by the sum of f, which is 80. So as we worked out, as we saw here, the sum of fm is 825. Oops, I don't need two equal signs there. So 825 divided by 80, and that will estimate the mean. 825 divided by 80 will give me an estimate of the mean of this data. So I take 825 and I divide it, 825, and I divide it by 80, and that gives me 10.3125. 10.3125, which actually I don't actually have to round that because it's an exact value. If I wrote it as 10.3, that would also be acceptable, but I'm going to leave it as this value. So that's an estimate of the mean of the data. So the estimate of the mean is 10.3125. The next part of the question says calculate an estimate of the standard deviation. Now the standard deviation is a measure of how spread out the data is, and it basically tells you an average of how far away each item is from the mean, the average distance of the items away from the mean. But there's a very easy, simple little formula that will help us to work out the standard deviation of anything. Now, first of all, the standard deviation is the square root of what's called the variation. The variation. Okay, and the variation is given by a very nice, easy thing to remember, which is equal to the mean of the squares minus the square of the mean. Now the mean of the squares minus the square of the mean, basically you take the mean of the squares of each entry in the data and you subtract from that the square of the mean of that data. So basically the mean of the squares of each item in the data, well, because we don't have what the actual items are in the data, we take the midpoints as our items and we square them. So we do 2.5 squared and 7.5 squared and 12.5 squared and 17.5 squared and 25 squared, and we multiply them by the frequencies. So there's 20 items. We just assume that they each are 2.5, so we do 20 times 2.5 squared plus 24 times 7.5 squared plus 16 times 12.5 squared and so on, and then we add all that together, which is actually the sum of fm squared, which is again given to us. So we don't actually have to bother doing any of that. That's just for me explaining to you what it actually means. But that's basically what this is here. That is the sum of, this is basically this is the square, this is the square of each of the terms. Okay, so the square of each of the terms, the sum of the squares of each of the terms is given by fm squared. So if you want to find the mean of the squares, okay, so this is like the sum of the squares, you could say. This is the sum of the squares of all the terms in the data. The mean of the squares is when you divide this by the number of entries, which would be the sum of f, the sum of the frequencies. So basically, we can say that the standard deviation is the square root of the mean of the squares, which is going to be the sum of fm squared divided by the sum of f. That's going to be the mean of the squares minus the square of the mean. We already found the mean up here, but I'm going to just write it as this. This is the sum of fm over the sum of f. This is going to be the mean, and I have to square that. Okay, so that's the mean of the squares minus the square of the mean. All right, so we can then put the values in that we have. So we have the sum of the squares is 12,012.5. So that's the sum of the squares, 12,012.5 divided by 80 minus the square of the mean. Now, when I take the square of the mean, I don't take this value here, although I could in this case because this is an exact value. Okay, I normally go to the original fraction, which is 825 over 80, and I square that fraction because most of the time your mean will be a rounded value, so it's best to use the original fraction. So you get into the habit of doing that, even though it doesn't make any difference in this case because that's an exact value. Get in the habit of using that fraction that you use to find the mean in this place here. It keeps your answer more accurate, that's all. So we can say now, therefore, the standard deviation is equal to this, the mean of the squares minus the square of the mean. So I'm just going to stick that in my calculator, and so I'll have the square root of 12,012.5 over 80 minus, I'll put it in a bracket because I've got to square it. I'll have 825 over 80, and then that has to be squared. Okay, that's correct. Equals, and that will give me my standard deviation, which is 6.6188, 6.6188, which rounds to 3SF as 6.62. That's the standard deviation, which tells us it's a measure of how spread out the data is. Okay, so now that's part A, B, and C. Now I'm going to move on to part D. In part D, we are asked to use linear interpolation to estimate the median of V. Now the median of a set of data is the middle term of that data when it is set in order of size. Okay, so we got to find the middle term of this data. So what we have to do here is we have to first of all think about in which group does a middle term lie. So first of all, what is the middle term, or where is the middle term? Well, we know that the sum of the frequencies was 80, so the number of terms in the entries is 80. There's 80 entries in the term. Now, the middle term, when you have a grouped frequency, you simply just, to find the position of the median term, to find the position of the median, not the median itself, but the position of the median, okay, is given by n over 2. Okay, n over 2, which in this case is 40. So it's the 40th term. The 40th term is the position of the median. So we can say the position of the median. Now the median is given a symbol Q2, but the position of the median is equal to 40, the 40th term. Okay, so now, where is the 40th term? Well, the 40th term lies in which group? We have to find in which group it lies in. So we can say that the 40th term is in the group. Well, we can see that there's 20 terms in the first group, and there's another 24 terms in the second group. So we can see that by the time we've got to the end of the second group, we're now on the 44th term. So the 20th term must be somewhere in this group over here. So it's in the group 5 to 10. Okay, so it's in that group. Now we got to find out how far along, or what the actual value of V is. So what is its value in this group? That's what we have to find. So we're going to use linear interpolation to do so. So what I like to do is I like to make a little line here that represents that group. And I know that the beginning of that group is 5 and the end of that group is 10. So what I'm going to do, on the top of the line, I'm going to write the actual value for V, the value for V. So it's 5 and at the beginning and 10 at the end. And at the bottom of the group, I like to write the position. So the position of, say, the 5th term, we could say, is the 20th position, and the position of the 10th term is the 44th position. So this group, in this group, there are 24 terms, okay, and the width of that group is 5 in terms of its value, okay. Now, we know that our median is in the 40th position. So let me say this is what Q2 is. I need to find its value. I know its position is 40. It's the 40th position. So if I want to find what Q2 is, I'm going to take the beginning of the group. I'm finding the value. Q2 is the value of the median, not its position. So I'll have 5 plus, and then I need to use a proportion because I know its position. So I can say, okay, the proportion along this group that Q2 is the same proportion that 40 is along this group. So this is like 40 minus 20, which is 20, divided by the width of the group. Now the width of the group is from 20 to 44, which is 24 units, times how wide is the group that we're actually looking at the value? The width of the group is 5. So it's this proportion along this group. So that's going to be 20 over 24 times 5. added to 5 will tell you exactly what Q2 is. So if I stick that in my calculator, I'm going to get the position or the value of the median Q2. So I take my calculator and I just stick this 5 plus, and I'm going to have 40 minus 20, which is 20 over 24. And I multiply that by the width of the group, which is 5. And that gives me 55 over 6, which is 9.167. 9.17 you could say. So 55 over 6, which is 9.17 to 3SF. Okay, so that's a value of Q2. Okay, we just rounded to 3SF, 9.17. That's correct. So that's what Q2 is. So now we found part D. Now part E says, hence describe the skewness of the distribution. Give a reason for your answer. So this distribution, we know the mean. Okay, we've got to compare what we found. So we know what the mean is. Now the mean of this data was, if we go back to the last, it was 10.135, was it? Let me just check. Okay, it was 10.3125. That was the mean of the data. And we know the median, we just found the median is 9.17. Okay, so we can see here that the mean is more than the median. The mean is greater than the median. Okay, now, you could say that the median is less than the mean, doesn't make any difference. Now, how do I understand how the skewness of the distribution is? Now, if something is perfectly symmetrical, where there'll be no skew, the mean, the median, and the mode will all be the same. Okay, if it has what's called positive skew, it will look something like this. Let me just try to make it be a bit more like this. Positive skew, where most of the data is like in the lower end. Okay, so it's like this. So this is positive skew, where the tail, you could say, points in the positive direction. And negative skew is kind of like the opposite, looks something like that, where the tail is in the negative direction. This is negative skew. Now, what you can think about is that the median is always the part that's higher up than the mean. Okay, the median is the part that's higher. So it's like if the median is less than the mean, okay, then you could say that if the median is less than the mean, okay, then the median is going to be more on this side, and the mean is going to go on that side. So the median will be here, and the mean will be on here. But if it's like the other way around, all right, if the median is bigger than the mean, then the median is going to be on this side, and the mean is going to be on this side. Okay, so whenever the median is less than the mean, or you can say the mean is more than the median, it's going to be positive skew. So you can say the mean is greater than the median, therefore it's positive skew. Okay, you could think of it as the median drags the mean along with it, kind of thing. So if the median is less than the mean, then most of the data is going to go towards the side of the median. Okay, so if the median is more than the mean, okay, then more of the data is going to be dragged towards the higher end. Okay, so that's how you can understand when data is skewed, when there's a difference between the median and the mean, then if the median is, whichever side the median, if the median is less, then more of the data is going to be on the lower side, so you're going to have positive skew. If the median is more than the mean, then more of the data is going to be skewed to the higher side of the data, and therefore it's going to be something which has a negative skew. Okay, so in this case we're going to have a positive skew. All right, so that's the answer to question part E. Okay, now for part F, it says calculate estimates of the mean and the standard deviation of the time spent using a mobile phone during the afternoon by the children in this club. So we need to find what we need to know what the code is. So we worked out that V is equal to T minus 5 over 10. That was a code that they gave us. And we worked out that the mean of the data was 10.3125. And we worked out that the standard deviation of the data was 6.6188 before we rounded it. and we got to work out what the actual time is. So we got to uncode or decode the data. So we can see from here that to find t, okay, now we got to first think about this carefully. All right, for the mean, okay, the mean is basically the sum of the data divided by the number of terms in the data. And if you add something to each term in the mean, it will change the mean. If you multiply each term, if you multiply to each term, if you take a set of data and you have a particular mean for that set of data, and you add something to each of those terms of that set of data, it will change the mean of the data. Okay, it will increase the mean of the data. And if you were to take the mean and you were to divide each of the terms by a certain value, it will also change the mean of that data. Okay, so the mean is affected by both subtracting and division. So the mean of the data, if I want to decode this mean of the data, I have to basically multiply. If I want to find what t is, I've got to take my mean and multiply it by 10 and add 5. Just undoing this. So 10 times v plus 5, that will give me the mean of the data. So I say 10 times 10.3125 plus 5 is going to give me my new mean. So I take my 10 times 10.3125, which was our mean or estimate of the mean, and I add 5 to that, and that's going to give me the actual data, which is 108.125. So that's the mean of the actual time. That's the mean of the time. Okay, the actual time, the actual data, 108.125. Now this is going to be in minutes because that was in minutes. So that's the answer for part. That's the answer for the mean. Now for the standard deviation, you see, it's the standard deviation is to do with how spread out the data is. Now, if I add something or subtract something from each term in the data, it won't change how spread out the data items are from each other. But if I was to divide or multiply each term by a certain value, it's going to change how spread out they are. It's going to, change how spread out they are from each other. Okay, so multiplication and division affects standard deviation, but addition and subtraction doesn't. So here all I have to do is I have to take my standard deviation from before. The original standard deviation was for V, the standard deviation of V, we can say sigma V, was 6.6188. So our standard deviation for the time, I can't write my sigma very well, is equal to, now I have to decode it by multiplying it by 10 only. So I multiply the V standard deviation by 10. I don't add 5 to it as well because the adding doesn't change the coding, or doesn't change the standard deviation. Adding something to each set of the data will still give you the same distance between each parts of the data. But if I multiply each data by 10, each term in the data by 10, it will change the spacing between the data values. So this is going to be 10 times 6.6188, which is going to be 66.188, which gives you 66.2. So we can say that the mean of the time is equal to 108.125 minutes, and the standard deviation for the time is going to be 66.2 minutes, and that's the answer for part F, and that's the answer for this question. Thank you for watching. Other questions from this paper I will try to place in the playlist that you should find over here. Other questions about this topic to do with frequency tables, you can find in this playlist over here. You can subscribe to my channel by clicking on this link, and on the top of the screen here you'll find other S1 papers you might be interested in watching. Thank you for watching, and see you soon.